This is a prehistoric old piston pump. These things were old when I first started here. That was years ago.
Hi guys, Fraser from Lifco Hydraulics. We have an old line Denison pump here. Old line means that it was probably about 40 to 60 years old. Denison supported a lot of these even after they moved to more modern pumps. They were supplying parts, but by the time I came to about 2015, they basically stopped making those parts. A lot of times you cannot get any of the spare replacement parts for them, so replacing them or repairing them is extremely difficult. Let's take a look.
Original Denison one?
Yeah, these are like Apex Denison, which are old
Obsolete.
as old. PV06. Customer sent it in for repair. It may be working fine. It could be leaking. It may be blown up inside. Won't know until we take it apart.
These old pumps that they don't get serviced a whole lot because they're not in a very demanding application. They are in something where it's let's say a 5,000 PSI pump, but they're only using at 2,000 PSI. So it lasts a long time. Also, if they needed to be serviced frequently, they would have replaced it with something modern by now because it's extremely difficult to service these. Also, these old ones, they're kind of bulletproof. As you see, they have about 3 to 4 times material as a modern one. They do last a long time. I would say that this one was probably serviced last maybe 20 years ago, if I had to guess. How long does a typical pump need to be serviced? I would say that if it's running for 24 hours a day, 7 days a week, you'd probably be looking at about 14, 15 months. If it's a 4,000 PSI pump and you're running it at 4,000 PSI, that's going to have a significant decrease in life. So in these types of ones, what they've done is they've overbuilt, or they put something that's more than what's required. They do that because they need the longevity. Things like in power generation or like a nuclear power plant or something like that.
It looks like it got damaged in shipping.
Snap right off?
Yeah, that's not a big deal. We could just put a new screw in there.
Yeah. Goes to tell you how old it is, though, because something like that could just snap.
Yeah.
Now, Adele's comment might seem a little strange, but it's actually right. A lot of these old ones have a lot of the knobs and screws sticking out of them. This pump wasn't being shipped across the world using UPS or some other carrier who was not being able to give it the care that it requires. So they have a lot of knobs. They have a lot of screws sticking out, protruding things. So yes, these old ones, they even looked archaic with the knobs on them. Now, I can tell you, no pump manufacturer is putting knobs on their stuff now. They don't want to encourage somebody going in there and just turning some knob because of it. So they put a lot of things behind requiring an Allen key, a lock nut, things such as that to prevent people from changing. So that's something that I've noticed over the 25 years that I've been doing this.
All those bolts are just your regular Allen key?
I could use an impact on them and get them off quicker, but anything under 6 mil, even 6 mil and under, I find if you use the Allen socket with the impact, 7 out of 10 times I might get away with it, but I'm gonna strip one and doesn't look too bad from here. I don't see any parts floating around in it, but a little bit of sludge.
And what's that part you're taking off?
It'd be like a servo piston, keeping it on stroke. It's basically just a spring, moves it in and out. You could probably adjust the min volume, so you could always have a little bit of flow at pressure. The compensator would send a hydraulic signal internally and then put it to neutral. So
That's as far as it goes.
that's it.
Has hydraulics changed in 40 years? If you look at the principle of this, it hasn't really changed much. This is a regulating pump, meaning that it's going to go full flow until some feedback from the system, the pressure of the system, is telling it to say, no, don't compensate for that, turn off. So actually, that servo piston there, that Lloyd was talking about would turn the control, turn the pump off. It wouldn't be turning it on. The pressure would then turn the pump off. You wouldn't want it the other way around, or else if you had no pressure, then the pump would never turn on either. So that'd be a problem. So in open loop, the spring is turning the pump full flow, and then the control is turning it off.
One thing that's kind of interesting about this that makes these hard to replace with a newer one is that these things are so old. The flanges were just something that, I don't know if it's an old standard or something, but it is not an ISO standard flange. So the mount is something special, and the pressure flange and suction flange are old and odd.
Watch that video of the SAE mounting flange. It actually is part of the ISO standard. People weren't really picking up on what I was saying there. Back then, it was the Wild West. Okay, it was machined, manual drawings. This had to match for that. They're plug-in. Now they conform to a standard. They're modular, much more inexpensive, easy to get, and you can solve problems within 20, 30 minutes as opposed to spending 3 days machining something.
So worth getting fixed if you can, instead of getting a whole new system.
Everything's possible if you pay the right people to do it. See if we get lucky and they come out easy. Again, pays to be a pack rat. That's a tool I made up, I think, probably 24, 25 years ago.
Yeah.
No idea where to get the proper tool for it, so make it. And it worked.
What's the ball?
That's like a pivot point for it. So this sits inside the barrel. This goes up, makes contact with the swash plate, and then the ball allows it to rotate around. The creep plate is what the pistons ride on.
Okay.
The port plate is what the barrel rides on. The barrel is in here still. The port plate for the barrel is underneath this. So this is similar to like the World Cup, where it has the port plate in the front, as opposed to the rear, like 75 to 80% of everything else we have.
Yes.
What can really blow your mind is this giant pump will now have the same displacement as one about half the size, because like everything else, as the technology gets better, it gets smaller. Yeah, this thing it's so old it has NPT ports on it.
What is about NPT that's no longer being used? The problem is that it's a tapered thread and it is single use. Because it's tapered, it's a mechanical lock that's happening that's distorting the threads on there. If you go back to our book on nuts, bolts, and general fasteners there, it's distorting the thread and it's moving it where it's becoming a plastic rather than elastic force on there, or distortion there, meaning that the threads are actually moving in a permanent manner. Thereby, it's single use. You can't unplug it, plug it back in, unplug it, plug it back in. You're going to lose that elasticity that keeps a mechanical connection between the threads. So it's just not a very good connection. It's far better to have bolts where you have an O-ring that's being compressed onto a face. It's reusable. You torque it to the correct amount. It's very straightforward.
That's not good.
Yep. Is it just on that, or?
Oh, it's fucked. But that's where the barrel and port plate are in the front.
Yet another Allen key size.
Yep,
What are we counting? 5 now?
pretty much. This setup is so old. When they manufactured it and they printed the book pre-internet, we actually get a binder with all the specs. It actually specified it had to be a matched set of bearings because the bearing manufacturing wasn't as good as it is today.
Okay.
And there could be a discrepancy of these of several thous. So you had to actually make sure your bearings were the same size.
It comes back down to that manufacturing capabilities. They were not able to create a tight enough tolerance. So what they would do is they would machine it, they would manufacture it, and then after they would lap it. So they'd put a lapping compound on there, and they'd lap the plate to the barrel, and they'd put a finer grit of lapping compound each time. And it could be a 6-8 hour process. But by the end, you have this perfect precision surface there, particularly ones where they had sort of the concave and convex surfaces. And this lapping compound is it's just a sandpaper. It's like sandpaper, but in a liquid. And you'd have there. I had seen them 10 years ago at the Parker's Marysville, is that they had some machines that were simulating the lapping of by hand on their old style barrel and pour plates. That's why a lot of times, though, they no longer can support those because the advanced manufacturing capabilities of it, they can't take that advantage. They still have to use these old school techniques on something that really should just get replaced anyways.
Did this guy have a key?
Yes.
Oh.
It's got a Woodruff key.
Yes.
Shaft seal doesn't look like it's been tore up. This don't look like it's too tore up. Shaft looks good. Pistons don't feel good, actually.
They don't?
No. Well, there's zero pull off. I don't know if you can see it on the video, but there is some belling happening here. You can hear the clicking.
Yep.
It should be smooth across. So if it's belling, it's banging, but it would probably be moving because of this. So the pistons have some belling. Barrel's completely pooched.
Parts for this is not easy to get, I assume.
Like I said, I think these were obsoleted when I first started here back in the 1900s. And if there's anybody that can find this stuff or know who has this stuff, it's Ed. Apex was Denison's owner before Hageland's, before Denison owned him again, before Parker bought him. Yes. So that's like 4 owners ago.
Now, what's changed with hydraulics? On these ones here, it's the same style of control, all of that, we still have that. What's really changed is the manufacturing. Our ability now, and we say our, I mean the pump manufacturers like Parker, is their ability to manufacture precision components is better now. Now they're able to, the tolerances are tighter with a repeatability. So they have these advanced CNC machines. Parker invests a lot of money into its manufacturing capabilities stateside. So the big one in Marysville, Ohio, and Otsego. Those are the big pump division ones. They invest quite a bit in automated machines, and those machines are far more capable now than they were 40 years ago. 40, 50 years ago, they were probably doing a lot of this manually. But now, with computerized systems and these advanced manufacturing capabilities, they're able to create tighter tolerances. They're now capable of making it smaller. They don't need as much material and all that because of they're able to just get finer precision with that machining.
Yeah, all I can do is make up a report.
These parts were pooched, and now we got it up on there. We were able to source some parts. I believe that we had some old units that were similar where we can use a few of the parts. Then we were able to get a few and rework some. We had to make a few parts. I don't want to show that. It's the secret sauce. It's the reason why people come to Lifco, so I don't want to show too much of that sort of stuff here. But yes, we were able to get this into a working pump. Now, if this might seem a little bit abbreviated, it's because it's lunchtime and I'm really hungry. So I could probably have a little bit more long-winded answers, but pay attention. We're going to do some posts on these sort of things because each one of these that we tackled on this one and the previous video that we just made, which was the P2105, has a lot of interesting concepts. So we're going to make a bunch of posts on there. Make sure, pay attention to the posts. And feel free to message us or comment if you want us to delve into something a little bit deeper. We have noticed, though, that a bunch of our viewers know just as much as we do, yet you still find this entertaining. So this is great. I know that there was the one gentleman who worked for Rexroth, and there was another one that was working on these ones down in South America. He was in wasn't he in some remote place in Argentina, I think it was? Yeah, it was very, very cool. So thank you guys so much for tuning in. We just got these Buy Hydraulics shirts in. Thank you so much for watching the whole video. Send us an email, sales@lifcohydraulics.com, with your address and size, and we're going to give a few out.